Today I'll be guiding you through the clean architecture in iOS. So the topics to be covered today are the components of clean architecture, what problems will it solve, code organization, an example of clean architecture with an Xcode example. Okay. So first of all, let's discuss why we need clean architecture. Okay. Suppose if a client comes to you with a bug in the project that you have developed, okay, and we all have a tendency to provide a guess estimate. And say if you provide an estimate, say of 2 hours to solve a bug, and it takes more time than what you have promised the client. So like then you get uh, have a tendency to go through the functions, like you may not know how much time it's going to take. So also you may do not know like how complicated the things are and where you have to look due to the bad architecture problems uh, of your code. Okay, so this happens. And also it might happen like the client might not know like how complicated the thing is, like and he needs to stop changing the requirements and should focus on the functionality and not the UI, etc., etc. And also like you have to understand the code again. You have to navigate through like 20, 30 classes, protocols, methods, stays through various conditional loops and everything, identified and reproduce the bug and make changes to see how it behaves differently and repeat till you fix the bug. Repeat all these things again and again. So it might take a lot of time. Okay. And then the guess estimate, and the client might get upset and you might lose the client. So this happens due to the bad architecture practice you have, the way you have coded using a bad architecture. Also, we call it as a massive view controller or a spaghetti code. So let's see when we use a proper architecture, what problems will it solve? Okay, so we'll start with clean architecture. Okay, the clean architecture is derived from the clean architecture proposed by Uncle Bob. Like we all know, Uncle Bob is renowned for the solid principles. His name is Robert Martin. Okay, we share many common concepts such as components, boundaries, and models. While Uncle Bob demonstrates clean architectures in Java and web applications, we'll see how to apply this clean architecture using Swift. Okay, the problems this will solve is with the clean architecture, we're able to fix bugs faster and easier, change existing behavior with confidence, add new features easily, write shorter methods with single responsibility, decouple class dependencies and establish boundaries, extract business logic from view controllers into interactor, build reusable components with workers and service objects, write refactored code right from the start, write fast and maintainable unit test, have confidence in your test to catch a regression, and apply what you have learned to a new or existing project of any size. So the main components of this architecture are the view, interactor, and presenter. It is like so we'll see in the VIP architecture in a clean Swift manner, okay, as a clean architecture. So it establishes one-way communication with view, interactor, and presenter. So view is what the user sees and interacts with. Okay, and the interactor will have we will communicate with the interactor. Interactor will communicate with presenter, and the presenter will again update the view. So this is a one-way architecture, and these are the three main components. So let's go one by one. So this is a view controller, a view or the view controller. So view controller, the its main responsibilities are updating the content of the views, usually response to changes to the underlying data, responding to the user interactions with the views, resizing the views, managing the layout and overall interface, and coordinating with other objects, including other view controllers in your app. Now, interactor. So this is the main component of the app, is the backbone. So in this interactor, it has the business logic. The user taps and swipes the if in your user interaction, it collects data from the view, and the view controller inputs it the data what the user has passed to the interactor, and then the interactor retrieves some data from the models and asks some of the workers to do the work. We'll see what are workers in the next slides. In the presenter, after the interactor produces some result, it passes the response to the presenter. The presenter then gets the response and converts it into view models for suitable display, and then passes the view models back to the view controller for display into the user. And router. So router basically handles the navigation inside the app. So when the user like wants to go to the next screen, he taps the next button and a seek is triggered and the next view is presented. So the router extracts the navigation logic out of the view controller, and it is also the best place to pass. If you want to pass data from one view controller to another, the router is the best place. So the view controller is left with the single responsibility of just controlling the views. So with the addition of router, the our diagram will look like flowchart will look like this: the view, the interactor presenter, and the view that will communicate with the router. And apart from the router, we'll have the worker. Worker are needed for this, like we have to fetch data from CoreData or the APIs, or download some data and follow. So we do not want to put the whole code inside the interactor and make it heavy. So to swam the interactor with less responsibility, we are moving this uh, fetching of the data from the from the APIs or the database to a worker. So worker will handle with all these things. So with the addition of this worker, the our diagram becomes like this. So it is the job of the interactor with to communicate with the worker. So if the worker is handling is fetching data locally, then we have to create a worker that will communicate with the core data. So it will have all the operations related to the core data. And another worker, if you want to fetch the network from the database, we have to fetch the users from the uh, network or some other data from the database. So we'll create another worker like a networking worker, so that it interacts with the interactor. Okay. So with these multiple workers, they will communicate with the interactor, fetch data, and the interactor will update the presenter, and the presenter will update the view. So models. So models are nothing but the data models. So what we usually use, like the user model, or we might have some orders or some uh, something to fetch from the database. So that we convert it into model. Like we make a request, like we have request model, the response model. So these are the three types of models. The request. So when we want to fetch something from the database, we create a request. So that can be converted into the request model and send it to the database. I send it to the server, and then we receive the response that can be converted into a response model and the view model. So view model here, it is not the view model from the MVVM architecture. So this view model is actually the interactor passes to the view to display it to the user. So this is the full architecture flow. So here the user taps the view controller controls it. And if it wants to navigate, it communicates with the router. And from the view controller, if the user wants to fetch some data and process some network request, it will uh, go to the CoreData worker. And CoreData, these workers will again fetch data from the services or models and again communicate back with the interactor. Interactor will then update the presenter, and then presenter will update the view controller. So after creating all these types, so for a screen, for one screen, your folder arrangement will look something like this. So you will have the login presenter for the presenter, login worker, login router, models. This is the view control view and the login interactor. So these are the files created after the after you create a scene or a view controller screen. For each screen, all of these files will be created. These main components. There can be a separate network layer that we'll see in the form of services when we are going through the live example. And then we can have extensions, singletons, helpers, constant that uh, s- store other functionalities, and also for better code structure and readability. Okay, now we'll see the live example of what I have created on the Xcode. So I have one app over here. Okay, this displays a list of orders, and here you can create an order. So this is the form to create an order, and I can save it. And we can see the order, edit it, and then again we can save it with some another thing. So this is the simple example what we are going to see through a clean architecture. Now let's move to Xcode. So this is the project structure of the Xcode. So here we have the models. This is the order model for the core data. So it has uh, the functionality like to save the uh, order details like the billing information, credit card number, etc., address, and user's name, user details, etc. And this is the core data model feature, and this is the order model. Okay, then we have the services uh, for this is the another part of that architecture. Okay, so these are not included as a component, but this is optional and additional, like to separate out uh, the functionality of the app. So this is to store the locally, to handle all the data locally. So we'll be using this for the demo. So this is to store in core data to locally. The core data is the local storage for the app. So like we can fetch the orders with the manage object contents. So fetch orders, create order, update order, and delete order from the local storage. And this is the API service. So this we are not using, just I have created some functions over here. So this will communicate with the database. And if you want to use this as a template, I'll provide a link to download this template. And then you can implement your own code to write the network functions over here. for the CRUD operations that will communicate with the server. And we have one orders worker, created a worker over here. So it is initialized with the orders protocol, and it will act on behalf of the interactor. It will communicate with the interactor for the fetching and updating of the data. And we have these three screens. So we have this list view controller. This is the view, and this is the list order interactor that will communicate with the workers and models and update the presenter. So this is the presenter. So once it receives data from the interactor, it will update the view through this protocol. So we'll see one create order. So create order, we'll see we have all these text fields. So which are the part of which these are the text fields. So user will enter data in it, and once the data is collected, once the user presses on save, so what it will do is when the save button is tapped, it will collect all the data from the text fields, and it will create an order. It will communicate with the interactor, and it will create an order. Now, what happens is, here is the orders worker. It owns the order worker, and for the service, we have initialized this order workers with this service to store locally. We are not using this CoreData and API for now. Just to display, we are using this order name service store. Sorry. So here we have in this store, we have orders. We have created two orders that you can see. This screen is to create orders, and what you can see, these two items are this. I've created some two dummy items over here. So once the list order is presented, it will fetch the orders, and the list order will communicate with the interactor in over here to fetch the orders. So interactor will again communicate with the worker over here, orders worker, to fetch the list. And once it receives the list of orders, it will update the presenter. So presenter, what it will do, the presenter will get the data and convert it into the view model, respective view model, and it will notify the view controller. It communicates with this through this protocol. So this is the display order protocol over here. So once it receives order, it calls this protocol, and then this view controller implements this protocol method over here, display fetch orders, and it is reloaded into the table view. Okay. Similarly, we have this create order. So we are same way. The view is communicating with the interactor to create order, and then this interactor is calling the workers to create order, and then sending the, after receiving the response, it calls the presenter when the order is created. The presenter is then gets the updated order and notifies the view through this protocol. And then we have this create order model. So create order with these fields, and we have order worker and a router. What router will do is it will navigate, it will communicate with the view like to go to next screen, like to show order, pass the data to order, and navigate to list, navigate back. And so similarly, we have the show order uh, screen. For this, it will we have the show order interactor. Similarly, we have the show order presenter, which will communicate with the worker, and sorry, interactor. It will communicate with the worker, and then it will update the presenter. Presenter will then update the again show order view controller. So this is how the uh, functionality of the uh, clean architecture works. So I'm creating one order over here. So I'm storing locally, say Raj, some. So I do not have any some cards, say. I'm saying this order. So by default, it is saved as this, and edit. Same way I can edit it. And save it again. So this is how the clean architecture usually works with this.